Hey Geometry 2 students, Ms. Craft here, and today we're going to be doing lesson 12.2, which is subdividing a segment in a given ratio, otherwise known as partitioning a segment. So partitioning a segment from a graph and partitioning a segment algebraically are the same thing. That's because I teach it the same way, because I think it's the easiest way to understand it. So I've given you some steps to follow along with, and I would recommend you use them, obviously, or I wouldn't have put them, but it does make partitioning a segment much easier. The first thing we're going to do here is find the portion of the whole, which is the scale factor. What I mean by that is, in our first example, we're finding the point P that partitions segment EF in a ratio of 3 to 7. What this means is 3 from E to P, 3 sections, and then 7 sections from P to F. So this isn't out of 7, it's out of 10 because there are 10 total sections, and we're going 3 sections to P and then 7 sections to F. So that's what I mean by finding the portion. So my scale factor is 3 out of 10. It is very important that we go from the first letter in our segment, or if you're given, partitioning from F to E or partitioning from E to F, the order does matter because our point would obviously end up in a different location. Okay, the next thing we're going to do is calculate our differences for our X and Y coordinates. So my X's, I'm doing E first, it's X sub 2 minus X sub 1. Okay, that's how we do it. So that's why I've labeled E as X sub 1 and Y sub 1, and F as X sub 2, Y sub 2, because E is my first point, F is my second point. So I'm doing negative 10 minus 10 for my X's, which gives me negative 20, and then negative 20 minus 20 for my Y values, which is negative 40. Again, this is from the distance formula, so you should know how to do X sub 2 minus X sub 1 and Y sub 2 minus Y sub 1 from Geometry 1. Then we're going to multiply each of our differences by the K value. So the K value we found is 3 over 10. The difference for our X's was negative 20, so I'm doing 3 over 10 times negative 20, which gives me negative 6. And then 3 over 10 times negative 40, the differences of our Y values, which gives me negative 12. You are then going to add the value that you just got, the negative 6 and the negative 12, to X sub 1 and Y sub 1. Make sure you add it again to that point that we're starting with. So I'm going to do 10 plus a negative 6, which we do not use double signs. You are not in middle school. So 10 minus 6, and then 20 minus 12 would be my X and my Y values, which gives me 4, 8. I then plotted the point 4, 8 and said that P is obviously at the point 4, 8. So that would be how you partition a segment. You have another example to the right that I left blank, and then 2 examples below where you have to plot the points yourself if you so choose, and then partition the segment. So this one, I've given you the coordinates 2, 4 for point A and 10, 12 for point B. And we're going to find the point P that partitions the segment AB into the ratio 3, 2. So again, we're going from A to B. So this time we're going from left to right because I plotted the points here. And the ratio is 3 to 2, which means that going back up to the steps, my scale factor is 3 out of 5, totaling them together. And then the first one is the one we're looking for. So K is 3 over 5. So I find the difference of my X values, 10 minus 2, X sub 2 minus X sub 1, and then Y sub 2 minus Y sub 1, which is 8. Okay, both of them are the same value. And then I multiply each of those by 3 over 5. 3 over 5 times 8 gives me 24 over 5. Now, this one is not a pretty number like the one at the top was whole numbers, and so it makes it a little bit easier. Now I have to add 24 over 5 to both 2 and 4, the original coordinates for my A value. So I did 2 over 1 and found a common denominator, so I multiplied by 5 over 5. That gave me 10 over 5, so I did 10 plus 24, that's how I got 34. Same thing here, 4 over 1 times 5 over 5 to get a common denominator. That gives me 20 over 5, and then I did 20 plus 24 to get 44 over 5. So the coordinates for point P are 34 fifths, and 44 fifths. And then to plot that, which you don't have to, but I chose to, you're going to mentally or actually turn this into a mixed number so that you can identify where it's at. So this is just less than 7, this is just less than 9, so that's where I plotted it, 6 and 4 fifths, and then 8 and 4 fifths. Okay, so that's point P. The next example is doing the same thing. So I would recommend practicing because following the steps is really easy, but maybe try to do it without looking at the steps. Okay. Like I said, partitioning a segment algebraically is the same thing, you just don't have a graph. So it's not quite as easy to check it. It makes sense to look at a graph and check to see if the ratio looks correct. But here you're going to have to just assume that you did the math right, or you can then draw a graph if you so choose. Okay, the differences between my x's and y values. I did 6 minus -3. That's how I got a plus here. Please don't double sign. There is no such thing. And then 1 minus -2, so 9 and 3. My scale factor is 2 out of 3 whole parts. So I'm multiplying 2/3 times 9 and 2/3 times 3 times my differences of x's and y's. So that gave me 6 and 2. Then I'm adding those values back to the original A value. I'm assuming, well, I'm the one who wrote the notes, so I intended for A to be my first point and the partition to be from A to B. So I apologize for not writing that. It'll be the same. Please use G as your first point and then T as your first point if you choose to do the next examples. So -3 plus 6 is 3, and then -2 plus 2 is 0. So point P would be at the point 3, 0. Okay, so again, doing the same thing, and then I would recommend that you practice with the next two that you see. All right, constructing a partition of a line segment. First of all, you should have a compass and protractor for this class because there are lots of constructions that come up, and you should have one from Geometry 1 anyway because there are lots of constructions. AZ Merit loves constructions, so I do want to make sure that we go through all of the constructions that HMH looks at, and then also just what I think is important as far as what I've seen on AZ Merit questions. Okay, so please forgive my not straight lines. My compass did not obviously stay set when I did this last point here, but in general it looks okay, so just make sure that your compass stays set as you do it. The first thing that we're going to do is draw a ray from the endpoint of our segment, and because we're going from A to B, it needs to be from point A. And you want to create an acute angle. Really, you can create any angle that you want, but it does make it a little bit easier and more accurate if you do a smaller angle. Sorry. Okay, then I drew circle A with any radius, and I marked an arc on ray AC. Okay, that's where I got D from. And I made sure that I made this small enough so that I could make 4 more or 3 more arcs like it, because I have to partition the segment into 4 parts because 1 and 3 is 4 parts. Okay, so please don't make your mark like halfway up the ray that you created. You're going to have to do enough so that it fits. Okay, I labeled that intersection D. And then I drew circle D with the same radius as circle A, and that's how I got point E. I did it again, that's how I got point F, and I did it again, that's how I got point G. That gave me my 4 parts. It does not matter the distance from G to C because I'm not using point C, that's just a label that I used to mark my ray. Then I have to connect my endpoint of B to the endpoint, the last point that I found, which is G. The important thing here is that the angle you've created here, angle BGA, is the angle that you need to find where the segments break up segment AB. So you're going to copy angle BGA, which if you don't remember how to copy an angle, first of all, it's in the Geometry 1 notes in HMH, but you can just Google it. There are lots of videos and people are very explanatory. It's pretty simple. Okay, so I copied BGA on point F, then I copied that using point E, and then I copied it using point D. What that did was break up segment AB into 4 equal parts. So part 1, part 2, part 3, part 4. I needed parts to be 1 to 3, so I did 1 part and then 3 parts from point P to point B. So that's what I did here. I labeled this point P because that would be what partitions the segment into a ratio of 1 to 3. That's all I have for you for lesson 12.2. If you have any questions, please send me a message in Canvas. Thanks.